Hey, Vsauce, Michael here. Water is all around us. We drink it in, we breathe it in, and we bathe in it. But what do you really know about it? It has many intriguing properties, some of which we are still not aware of. For example, we only recently could confirm that water becomes superionic at high temperature and pressure states like those found in our ice giants, like Uranus and Neptune. This phenomenon was first predicted in 1988 by Percy Bridgman, a Nobel laureate. And following that, there was a long history of confirmation and then refinement of the theory through numerical analysis and computer modeling and static compression techniques. So all of this returned mainly positive results and seemed to confirm this theory, but nevertheless, there was no hard experimental evidence which could confirm or deny this theory. Until now, that is. A research team recently found that by compressing water to 60% more of its density than normal, and then sending pulses of UV light at it to both compress it and make it more excited, and therefore increase its heat, they could mimic the conditions at which superionic ice was predicted to exist at. And they shockingly, or not shockingly at all actually, found the thermodynamic signatures which suggested and verified two of the main predictions of superionic ice. One, high protonic and ionic activity, and second, an extremely high melting point. So this was a lovely experiment, whose one-liner would be something along the lines of experimental evidence found superionic water using shock compression techniques found nothing new or strange, and completely was affirmative of the 30-year-old theory. So this experiment was led by Marius Millet as a collaboration between the USA Department of Energy and the University of California, Berkeley, and the University of Rochester.
Now we'll be talking about whether this article is deductive, do we believe it, and the knowledge question that we developed behind it. Do we know if this article is deductive? Well, first of all, we have to remember the definition of deductive reasoning. Deductive reasoning is to draw conclusion from already known facts. So, with math, for example, we draw conclusions from the axioms that we have discovered. Knowing this article was actually proven by math 30 years ago in 1988, one can conclude that this is a deductive article since it's really just proving the mathematical simulations that were already discovered in 1988. Because in 1988, according to the article, numerous mathematical simulations were conducted on superionic ice. However, it's just that we did not have physical data until 2018 in an actual lab. So we know for sure that this article is based off of deductive reasoning. How valid is the article and discoveries? Well, first let's delve into the discoveries. The discovery of superionic ice isn't something new. It was already discovered mathematically in 1988 using of course mathematics. So the only difference is the fact that we didn't have it physically with physical data, because we didn't have the technology for it. We only have math simulations and computer modeling. So now that we have physical data of it, it's amazing. So it's not really a question of the information being valid, because it 100% is. And the math predicting it was 100% correct. However, let's delve into the validity of the article itself. Is the article actually valid? Well, the article was published by Science Daily, so already Science Daily has a good reputation for being uncorrupted, to say the least, and have really accurate articles. Furthermore, after researching a bit, we figured out that this article was written based off of the publishings of a journal published in Nature Physics. And after searching Beale's Law, which was updated 21st of February 2018, so it is up to date, we know that Nature Physics is not a predatory journal, so it was peer edited and it had to go through the requirements to be published. As a result, I am confident that all the information in it is real. which leads us to our knowledge question that me and Syed developed, which was, to what extent can computer modeling and mathematical simulations be used as valid deductive reasoning? To what extent can we just use mathematical simulations and computer models instead of real life for deductive reasoning? So that was a question we thought of, and to be honest, there isn't really a clear-cut answer. And that's what we'd like to talk about later on.